Hi folks, this is the burning magnesium % yield lab. I have a crucible without a lid and its mass is 15.26 grams. But just in case there's water or some other residue on the crucible, I am going to briefly heat this to drive off any water or burn off any residue. Okay, this is heated for 2 minutes, so I need to let it cool before I measure its mass again. So I'm going to wait a few minutes for it to cool. Okay, it's been a few minutes of cooling time, so I can weigh my empty crucible again. And the weight of my empty crucible is 15.21 grams. Now, I have about 10 strips of magnesium ribbon that I've cut to about 4 centimeters long, and then I've loosely coiled them. We are investigating the reaction between magnesium and oxygen gas, so I need oxygen gas to be able to reach all the parts of the magnesium ribbon. After adding the magnesium ribbon to the crucible, the new mass on the balance is 15.87 grams. And I'm now ready to heat the crucible to start the chemical reaction. I'm just going to make sure that the crucible is in the hottest part of the flame, which is the tip of the blue cone that's in the inside of the flame. Remember that when magnesium ribbon burns, it gives off ultraviolet light, so you should not look at it directly, but you do want to monitor the progress of the reaction. You want to keep track of when the flashes of white light stop. So looking to the side of the crucible is the best way to do that, not into the crucible, so that you do not damage your eyes. Been heating for 15 minutes, so I'm going to turn off the gas and let it cool for 5 minutes before taking a final mass reading. The crucible has cooled for 5 minutes, so we can take a final mass reading. And the final mass reading is 16.26 grams. So now we have all the data we need to calculate the percent yield of magnesium oxide from reacting magnesium metal with oxygen gas. As you can see, the magnesium oxide product is flaky, very brittle, crushes into a powder, and a different color than at the start. More white and less silvery.